Hi everyone, my name's Alan O'Reilly. I'm a systems engineer which sits in Cisco's enterprise segment, looking after all our enterprise customers. And today I'm going to talk about enterprise automation. So automation's actually becoming front and center of conversations now. You can see it's actually one of the key tenets of the DNA strategy or architecture. And I guess one of the questions is, why is it becoming front and center? Analysts are actually saying that the cost of a network these days, about 2/3 of it is actually operating the network. So that's doing the configurations, changes, troubleshooting incidents, that kind of thing. And only 1/3 of it's actually the cost of buying the equipment in the first place. If we sort of look further into that, we can actually see what are people spending most times on, and it's things like change management. So it's updating ACLs, which is a pain to everyone. It's making changes to VLANs, to port configurations, that kind of thing. The next up on the list is incident management. So if something's gone wrong, something's caught fire, so to speak. It's how do we deal with those incidents. We then actually queried a number of customers to say, look, we know that you've got all these sort of complex problems. What are you automating today? So we sort of filtered these into companies smaller than 100 IT staff, companies larger than 100 IT staff. And typically, actually, when we ask them what they've automated, they tend to say, well, actually, we're pretty good at doing network monitoring, but the pieces that we have trouble with automating are around device installation. So how can we just ship a device to a site with never having to unpack it, stage it, repack it, ship it to site? How do we do that? And how do we do change management in a scalable way? And remember that change management's actually one of the biggest ones that is driving this OpEx. But to give you a number, 60 billion, that's $60 billion a year that customers throughout the world are spending on just operating their networks. And that's not getting any better. That's growing at about 6.5% a year. And it's actually growing faster and faster every year. So it's not going to be long till we hit the $100 billion mark on managing networks. So that's really why we're talking to you about automation, why automation is one of the key pain points for our customers. So we've actually got lots of automation tools. So we've got things like TLF that Cisco acquired for automation. We've got ESA, which we talked around this morning, but I want to really focus in mostly on APIC-EM and introduce that to you today. And then I'll talk a little around device level programmability. So if we're not going to use a controller, how do we talk to devices better? And then I'll sort of also talk about how do we do DevOps style interactions with network equipment. And I'll give you a demonstration of that. So really, what we're trying to do with APIC is get away from all the sort of device CLI configurations. We're trying to abstract with the controller. So what we want to deal with is the business intent on the right. So we want to say that we want to keep finance separate from engineering. So engineering can't go access finance documents. Guests, contractors can't go access finance documents. That's our business intent. But today it goes through the brains of somebody in IT and they end up writing some sort of ACL and then go put that on routers, switches. And by the time they've done that, if anyone to look at the ACL, they wouldn't be able to understand the business intent behind that. So what we're going to do is we'll work to actually say what that business intent is, feed that into the APIC, and then APIC will do the necessary changes in the network to actually meet that intent, to meet that policy. So there's never been a better time for a demo. So, I'm going to introduce you to APIC. So just a quick straw poll. How many of you know about APIC-EM already today? So a reasonable amount. And how many have had hands-on with APIC-EM? So a couple. All right, cool. So this is APIC-EM. So this is our controller. On the left here, we can see the built-in apps. So we've got some we're still in very early days of APIC-EM, so this is release 1.2. We released APIC at the beginning of the year. And these are the apps that we're currently shipping today. So I'll go through some of the apps. So just to begin with, we've got a nice little device inventory utility. So anything that's been discovered in the network, we'll present that here. So we can see every single device, what the status of the device, last time we managed to speak to the device, uptime. We can also filter on lots of different things. So we can look at hardware. And in this view, we can easily tell what version of software they're running, what the particular platform is, what their serial number is. And actually, we can even look into their configurations for the tool if we want to as well. And another view we can actually look at is tagging. And we'll use some of the tagging later on. But we can see here, we've got a column called device role. So when we actually go out and discover the network, based on how the devices are connected up, so if a device has got 2 uplinks and has got a bunch of users connected to it, we can pretty much determine that that's going to be an access switch. If we've got some access switches connected up to a switch in aggregation, we can tell that's going to be a distribution switch. So we'll actually automatically populate these just with knowledge. But if they are wrong, you can just use this drop down to change them. We also can tag location, and that starts to become interesting a bit further on. And the other thing we can tag on is policy. So in this policy, I can tag anything that's similar. So in terms of this, we're going to use it for quality of service. So if I've got a particular campus access that I want different quality of service than, say, another branch, I can just tag them with different policy tags. And that allows me to dynamically set the quality of service using the EasyQuals application. So that's device inventory. I'll just jump now to host inventory. So this host inventory, we can actually have a real-time view of every single client connected to the network. We can tell you their IP address. We can tell you if they're wired or wireless. If they are wired, what port they're plugged into. So we can actually provide that information, and it's kept up to date. So you can either come in here, search for a particular user to work out what port they're connected to, or actually everything in APIC's presented through an API as well. So if you wanted to write a quick script where you can just search for a person's username and it will come back with what switch they're plugged into, what config's on that switch, that's very, very simple to do. Next up, we've got topology. So quite often with my customers, they've never done visual diagrams of their network, and when you ask them to talk about their network, they end up sort of scribbling it down on a napkin or something. With topology, you don't need to do that anymore. So this topology was built only based on discovery. So we just went out, discovered the network, and APIC-EM then presents this topology to you, and it will actually lay it out. So you've got your users down here, access point, access layer, distribution, core. So it's actually automatically laying that out for you. If you're in a big network, you can aggregate these together. So if you've got 1,000 access switches, you can aggregate them all together to make this topology still viable. And also in the previous device section where we set location, we can actually have a world map. So you can put where your offices are, click on an office, and that will give you the individual topology for that office, which is quite nice. And this is kept up to date. So IWAN, I'm not going to go into IWAN because Tiago's already covered this. But in essence, we've got an application with an APIC-EM where you can manage your full IWAN solution. That includes the initial provisioning of it and then also the monitoring of it. And if you had some sites, this is the map view. So if you had some IWAN sites here, they would appear on the map. You could click into them, look at the status of them. So next application we'll look at is path trace. So path trace is really cool for as a sort of operational tool. So at a very high level, what path trace is like traceroute on steroids. So traceroute's quite good, but it actually only shows you routed hops, which isn't very useful. if we look at this, because APIC knows all the devices in the network and can speak to them, APIC can actually go, you can specify to APIC, you can give it the IP address, the source and destination. You can give it the port numbers as well. So you've got, whether it's TCP, UDP, so you've got the 5 tuple. So you can actually work out deterministically exactly what path across the network it's going to take. Here you can actually see, so we've got this, any one of these blue lines is switched, so we wouldn't necessarily see switch paths in a trace route, but actually you can make out here as well, there's a cylinder and CapWap. So this is actually a wireless user, and we're actually looking at where the CapWap tunnel is getting switched across the network, and we're actually telling you what switches that's going through. So actually if you were to do a trace route here, actually all you would see from that client would be this hop here, and then we disappear into the clouds, and because we're going to 999, that's somewhere off in public internet lands, so we don't know the destination. If it was a destination in my network, we could show you the destination and what port it was connected to. The other thing here is that we actually can provide what ports you're actually coming in and going out on any device. And we can actually do further things. So if you've got an ACL that's filtering your application, we can tell you what device you ran into that ACL on and what part of the ACL you're actually hitting that's denying you. So it's really good for troubleshooting. And we can also do things like we can take statistics off the interfaces. So if you've got a congested WAN link, we can tell you that you're actually dropping packets on the WAN link. So if you've got a user having some issues, say, connecting to Exchange, you just put the IP address of Exchange in, the host's IP address, and then run a scan, and it can actually say, well, actually on your WAN, you've got an ACL that's filtering this out, or on your WAN, you're actually dropping packets. So that is path trace. Then just look quickly into network plug and play. So within a network plug and play, this is how we can actually ship a device to site without ever doing pre-staging of it, plug it in and have it talk to APIC and pull down its configuration. So if I was just to go add here, I'd just put in the device name, its product ID. So we've pre-populated all the product IDs, so you just have to search for it. So if I go, say, 3850, this gives me a list of all our 3850s, and you just choose the appropriate one for the list. You give it the serial number. If you want to update the image on it, to give it new software, you can declare it here. You can specify your configuration here. And actually on some things, so on things like your product ID and your serial number, those are actually when a device is getting shipped to site. So the moment it leaves Cisco's factory, we actually know what they're going to be, and we can actually, in the sort of shipping invoice, we can actually tell you what the serial number is going to be. So you can actually pre-populate these before they ever get to site. So literally when they do get to site, it is literally a case of just plugging them in, and they'll come up and get their configuration. I know that earlier we had the question of, during the IWAN, of how do these actually get configured. So on any switch router of late, we've actually put a PnP agent on it, and that agent wants to go out and speak to the APIC-EM. And the way we tell the agent where the APIC-EM is, we've got a number of methods. So the easiest one is we can use DHCP. So we can actually put into option 43 the IP address of the APIC, and as soon as it pulls down an IP address, it will then know where APIC is, and then it can pull its final configuration. We can also do it with a DNS record. So we've got a pre-populatable DNS entry that will just point to your APIC server, and that can go resolve it. In the use case of, say, a branch router, then we also have the ability to do a cloud redirect. So that's when you plug the router in, it'll actually go, when it's going to the cloud, we can actually steer it in the cloud. So this is actually technology that's been in set-top boxes for a very long time, part of Scientific Atlantic, which is a Cisco company. We've shipped millions of set-top boxes, and they're actually doing cloud redirect today. So when we bring that support into APIC, it means that when you plug a router in, we can redirect it to APIC-EM. You do have to do some work on the WAN to be able to actually resolve to your APIC-EM. And the final way, if that's not an option, is we can actually put a configuration on a USB stick, ship the router with the USB stick, and if it boots with the USB stick in, it can pull the configuration off the USB stick. So we've got quite a number of options with plug and play. Actually, the other one I should also mention is we can do it with mobile phones as well. So we've actually we work with some vendors that we've got a lightning connector to console, so you can connect your iPhone straight to a switch. We also do a Bluetooth version, so you can Bluetooth from any phone to console. And we've released an application that will give the first bit of the configuration enough of the configuration so it can get out and talk to APIC-EM. So again, that's useful in use cases like routers, where you might have ADSL, where you have to do some configuration before it will be able to go out and speak to APIC. And one of the final applications that we've got today is EasyQAS. So this is how we can manage the full suite of QAS across all our devices in a simple user interface. So if I come here, we already pre-populate a number of applications. So we pre-populate, I think, 1,300 odd applications within it. And that's part of the CVD. So if any of you are familiar, we've got a CVD that thick of how to deploy QAS in a campus. We can do that booklet in one click or a couple clicks with the EasyQAS app. It's that simple. So we've got a bunch of pre-populated applications. Everybody's got their own custom applications, so that's easy to add. We can just go in, add the name of the application, and what we're going to use to match it. So whether it's IP addresses, port numbers, those kinds of things, so we can add them. You can also see here that under some of these applications, we've got yellow stars. And what those yellow stars actually mean is these are the favorites. So these are the applications that are most important to you, because we know that on some of our platforms, we might have limited table sizes, which means we might not be able to go push the 2,000 odd applications that you have in your environment, because the switches just don't have enough hardware to support that. If that's the case, it's going to pre-populate those star ones first. So the most important applications to you are programmed first, and not the ones at the end that are probably not all that relevant to you. I'll just jump across to policies. So if I wanted to create a policy, so earlier when I was tagging, if we recall the policy tags, these are where the policy tags are used. So I've got enterprise branch QAS scope. And if I wanted to make a branch QAS scope, I just click create on policy. And preloaded is the Cisco validated design. And rather than giving you 8 queues, 10 queues, whatever, we want to simplify this down. And what we're actually going to give you is 3 buckets. We're going to give you business relevant, so what's important to your business. We'll give you a default, and then we'll give you business irrelevant, so stuff that's really not important to your business. Depending on the actual hardware you're pushing it to, that it will either use the full 8 queues, or if you're on a 2960X, we'll use 4 queues. We'll actually work out what's most important within business relevant. So we'll make sure that voice is going into the priority queue, and maybe some important bulk data stuff's going into one of the shared forwarding queues. If you don't like where we've put stuff, it's literally a case of dragging and dropping. That simple. And the CVD comes preloaded in it. And when I'm done, so I'll need to give it a name. So just say QS. I just click apply policy. And that's going to go out and bespoke configure that on the devices. And depending whether it's a 2960 or a 3850, they're going to actually be very, very different configs. And yeah, just to give you an idea, when I clicked apply there, if that was a 2960, we were actually going to push about 1,100 lines of CLI just from click and apply. And typically when we've seen customers start to use this, they'll want to use it in a lab first. and they'll want to try and break it. And every time they push a policy, they're going to log into all the devices and see what's actually been pushed CLI-wise. And they'll basically keep doing that and keep trying to break it until they're actually like, yeah, we're actually quite comfortable. We know what's going on here. Let's maybe push it out to a small portion of our network and start managing it that way, and then gradually grow the bit of the network, because it is a bit of a leap of faith saying we've got this brilliant controller, stop doing CLI completely, just trust us. We sort of have to start building the trust with the controller. Just now we've got to be able to support with controller-wise. I'm sure you know in the data center world with ACI, we came out with new switching to support the ACI model. In the campus, we've not done that. We've purposely made something that will work in brownfield sites. So we know in campuses, you don't refresh them all at the same time. They're going to have one of basically every product we've ever made. So we have to be able to support brownfield deployments. So on older generations of devices, we actually open up an SSH tunnel, and we're actually pushing CLI down that. So we don't need any smart APIs or anything on the devices. So on the actual pushing of CLI, it sort of trickle feeds it. So if you're pushing it by CLI, it's going to be slower than pushing it by a native device level API. So it's going to be slower, but that's to make sure we're not going to sort of do any overruns or anything like that on the buffer. So one of the other problems that we've had is how do we talk to a device? So how does a machine talk to a device? Because CLI is human-centric, well, relatively human-centric. And it's not great for a machine to try and talk CLI, because if you're writing your own scripts, you end up doing expects, and then you're expecting a particular phrase, and then the router does some logging command or something, and that breaks your program. So it's actually quite hard to do scripting to a device. And the way around this is that we want to provide an API into the device, so a native machine API. But we want to make it firstly loosely coupled, so it's not basically tightly integrated to a platform, and every platform's going to be different. We can't do that because that gets us nowhere really. It's going to be just as complex as CLI is. We want it to be standards-based as well. And where the standards basically going is with netconf. So netconf 13's just been ratified, and restconf. So restconf is a RESTful implementation of netconf, and it's going through the standards just now, but we're going to support that. So we support that today on iOS XE 3.17 on routing platforms, and we're going to support it on 16.3 or 16.4 on a lot of the switching platforms. And this is going to be restconf. One of the major things behind restconf is this Yang model. And Yang's basically how we describe the API, so it's a model. And basically what we do with Yang is that Yang's going to be supported across the industry. And so we'll have some basic stuff, so that's going to be interfaces, that kind of thing, telemetry on the device. But we know that we've got some things that are Cisco only, so say OTV, so overlay transport virtualization, that's not an industry thing. So we're going to come out with some of our own models to support things like OTV. So you're going to be able to use the API for all the features of the device, essentially. So next problem is, if we've got all these cool automation tools, how do we actually use them? Because we know that not everybody's a programmer, and they're not going to be able to write their own REST calls and all that kind of thing straight away. So how do we actually make it easy to interact with it? And how do we actually make these tools consumable by things like help desks or by service owners to know that their applications are running okay on the network? So we've actually got lots of ways of doing this. So one of our colleagues, Bruno, a couple of years ago, he came up with a router that would tweet. So he would have a router that would actually upload its status onto Twitter a couple of years ago. It's a nice example, but probably not something you would ever use in the real world. But what we do actually have is Cisco Spark. So that's our sort of a collaboration tool that you can use for interacting with your team. We can Cisco Spark has APIs. We can use those APIs to speak to the network, and we can just talk normal English to the network. We've actually got some GUI framework. So when you saw that topology that was in APIC-EM, we've actually made that available, and it's on a pretty open license. So you can actually start to build tools with that topology in it and use those tools for your customers. And finally, we've got Tropo. So Tropo is voice interaction. So if your network falls over, you can have it automatically phone whoever's on call and tell them the network's fallen over, and say yes if you're going to come and deal with it. Say no if I have to phone somebody else. So I'll give you an example of this. So here in this browser, so this is Spark. So this would be, I could invite a bunch of my colleagues into the room and interact with them. But in this case, I've actually created a bot that goes and speaks to APIC-EM, and I've invited that to the room. I've actually made the bot be able to speak normal English. So it's something, chatbots, they're actually becoming increasingly popular because lots of IT guys were getting messages from service owners saying the same things: as my service up, is their problem with the network. So they actually automated the response, so they didn't actually have to speak back to them. They could just have a bot that would say, yeah, everything's fine in the network. So I'm going to try and speak to APIC now. So I can ask it what its name is. Comes back with APIC. I could ask it a simple maths question. So what is 9 plus 2? Comes back with 11. We can even ask it to tell a joke, so tell me a joke. It's a bit of a comedian. I could tell you a joke about UDP, but you might not get it. So you can sort of have an English-style conversation with this. So I wrote a little scenario out where a help desk could actually use this to troubleshoot the network, rather than having to jump into CLI, that kind of thing, that they might not have the privilege to do. So I can say, get network health. So this is going to then go off to the APIC, and it's going to query all the devices and say, are the devices reachable? So you can see here, it said that in my network, I've got 12 devices and they're all reachable. So that's quite good. I can also ask it what hosts are on the network. So in my scenario, I've only got 3 hosts, which makes this quite manageable. If you had 1,000 hosts in your network, this is never going to work. So what I can do is say get host Alice. So if I've got something that knows what Alice is, so that might be ISE, it might be Prime Network Register. If they can know what a username to IP mapping is, I can then go and speak to APIC and say, are they connected to the network? So I've just done get host Alice, and the network and APIC came back to me and said, yes, it's connected to the network. It's told me its IP address, the MAC address, what switch it's connected to, what port it's connected to, and what VLAN it's connected to. So that's something that even if you're really, really good on CLI, you might be jumping between tools, typing lots of CLI, so that might take a bit of time. In this, I just literally put get host Alice. I could also do get host Bob. So again, with Bob, he's connected to the network. I've got a MAC address and IP address. This time, he's connected to a wireless access point, so I don't have a port or a VLAN for him. But I know that both Alice and Bob are connected to the network. So in this little scenario, I can say, well, they're both connected to the network, so why aren't they able to speak to each other? And we saw in APIC that we have this cool path trace tool. So I could just go get path Alice Bob. So this is then going to go to the APIC, and it will then in the path trace, it's going to put the IP address for Alice, the IP address for Bob, and it's going to run the path trace. Path trace goes out and queries some live information, so it typically takes, depending on the size of your network, somewhere between 5 and 15 seconds to go out. So it's came back, path is complete. and this is actually giving me the path between them. And on this, I haven't got it highlighted, but again, this is using the power of path trace, because that highlighted part, that's all inside the CapWap tunnel, which again, Traceroute would have just never have seen. So I can see now, both connected to the network, they're both able to reach each other okay. So in my help desk scenario, this has got a bit too complicated for me. So what I can actually do is say raise, and then for Alice, I can give an urgency, so I'll just say 3, and then I'll give it some description, so the user is having network issues. So I'll post that into my bot. And now, rather than APIC responding, see here, if it loads, it's actually ServiceNow that's responded. I've actually just raised an incident in ServiceNow using nothing more than a sentence posted into a Spark room. It's pretty powerful. And more than that, if I come down here, you can see that I raised, so I've got a wee note saying that I've raised this case from Cisco Spark, but I've actually also populated Alice's IP address or MAC address, where she's plugged into on the network. I could even have put that path trace in here if I like. So actually, I can do a lot of the troubleshooting methods automatically as soon as a case or an incident is raised in a service management tool. And that's just basically going out and using intelligence from APIC. So this is brilliant when you've got a case. Typically what happens if you've got a case with a user having network issues, by the time somebody comes to look at the case, the problem's gone on the network and they never know what it is. As soon as this case is raised, you could do that path trace, which would give you that snapshot in time.